Hello students, in today's lecture we are going to discuss about the properties of ionic compounds. So to learn about this we are going to do one activity over here. So take samples of sodium chloride, potassium iodide, barium chloride or any other salt from the science laboratory you can take. What is the physical state of these salts? Take a small amount of sample and a metal spatula and heat directly on the flame. Repeat with other samples also. What did you observe? Did the samples impart any color to the flame? Do these compounds melt? Try to dissolve the samples in water, petrol and kerosene. Are they soluble? Make a circuit as shown in the given figure and insert the electrodes into the solution of one salt. What did you observe? So test the other salt samples too in this manner. What is your inference about the nature of these compounds? So now we are going, this activity we are using to understand the properties of the ionic bonding, how the materials are the compounds are going to behave. So ionic compounds are formed by transfer of electrons from metal to non-metal. These result in oppositely charged ions that are held together by strong electrostatic forces of attraction. This we observed in the previous lecture. So if you observe in this table by doing these activities, NaCl, lithium chloride, sodium chloride, lithium chloride, calcium chloride, calcium oxide, magnesium chloride, all are ionic compounds only. So how the melting points are there, how the boiling points are there, these you can observe here. They are mentioned in the degree Kelvin values. So you can observe what these following general properties, physical general properties of the ionic compounds. So the physical nature. What is the physical nature? They are solid and crystalline at room temperature. So the physical state is solid and crystalline at room temperature. Form crystals because of the regular arrangement of the ions. Okay, and what about the melting and boiling points? So ionic compounds, due to strong electrostatic forces between the ions, a lot of energy is needed to break the bonds. Hence they have high melting and boiling points, that you can make a note about that, right? And solubility in water. Most ionic compounds dissolve in water. Water molecules surround the ions and pull them apart, making the compound dissolve. So that is the solubility in the water. And electrical conductivity in solid state. What about the electrical conductivity, conduction of electricity? In solid state, ionic compounds do not conduct electricity because ions are not free to move. Okay, but in molten state or when dissolved in water, they conduct electricity, as ions are free to move and carry electric current. These things you can observe from the activities. Now we discuss these questions. Write the electron dot structure for sodium, oxygen and magnesium. So electron dot structure represents the valence electrons using the dots around the chemical symbol. So first coming to sodium. So what is the atomic number for sodium? It is 11. So you can represent the dot structure as simply Na with a one single dot, because the configuration is 1s2, 2s2, 2p6 and 3s1. So that one electron is shown with a one dot. Coming to oxygen. How to represent for oxygen? For oxygen the atomic number is 8. So electronic configuration is 1s2, 2s2, 2p4. Right? So valency electrons, how many valence electrons are there? 6. So you can show with the dots like this: 1, 2, 3, 4, 5, 6. This is the dot structure of valence electrons for the oxygen. Coming to magnesium. Magnesium, what is the atomic number? 12 is atomic number. So configuration is 1s2, 2s2, 2p6, 3s2. So in the valency, how many electrons are there? 2 electrons are there. Simply you can show magnesium with 2 electrons in the valency. Like this you can show with the dot structure. Coming to second, show the formation of Na2 O and MgO by the transfer of electrons. So formation of Na2O, sodium oxide. So each sodium atom loses one electron, becomes Na plus, and oxygen gain 2 electrons and it becomes O2 minus. So 2 sodium atoms are needed to balance one oxygen atom. So what is the relation here? You have to observe. Sodium is losing, 2 sodiums are losing their electron to become anion, and 2 electrons are getting released in this formation. Similarly, one oxygen is gaining 2 electrons from 2 sodiums and it becomes O2 minus and it is becoming oxide oxygen ion. So what is the final compound? Na2O. Like this you can explain. And formation of the magnesium oxide. Magnesium loses 2 electrons to become Mg2 plus. Magnesium loses 2 electrons to become Mg2 plus, and oxygen gains 2 electrons to become O2 minus. So here one magnesium is enough and one oxygen is enough. So one magnesium loses its 2 electrons to form Mg2 plus 2 electrons are released, and oxygen is gaining these 2 electrons to form O2 minus. In this reaction, what is the compound that is getting formed? So Mg plus O is giving rise to MgO. That is the chemical reaction. This is the ionic bonding and magnesium oxide is formed. Next question. What are the ions present in these compounds? So in the sodium oxide Na2O, ions present are sodium ion and oxide ion. Sodium is a Na plus ion and oxide is O2 minus ion. Coming to MgO, magnesium oxide, ions present are magnesium ion and oxide ion. Magnesium ion is Mg2 plus and oxide ion is O2 minus. Okay, next question. Why do ionic compounds have high melting points? Ionic compounds are formed due to strong electrostatic attraction between the positively and negatively charged ions. This you already observed. So this ionic bond is very strong. So a large amount of energy is required to break these bonds. That's why ionic compounds have high melting and boiling points also. That is the explanation.